intermediate code it is used intermediate code is used to translate the source code into the machine code. So to translate the source code into the machine code, we use intermediate code, and intermediate code lies between the high level language and the machine language. So suppose it is a source code which is nothing but the high level language, and it is the target code means nothing but the machine language code. So intermediate code is something which is existed between the high level language and machine language and the machine code, right? So it is, you can say that, one kind of machine relocatable code which needs to be used by linker and loader and code optimization, and after that it will be passed as a target code to the machine. So it is the intermediate code definition, right? It is the theoretical topic, theoretical definition I have discussed with you. And if we talk about intermediate code, guys, then we can consider there are several type of intermediate code. I am discussing it with you. Intermediate code, right? I am discussing what is intermediate code, what kind of intermediate code basically existed, so that you can understand it with somewhat real example, and then you can focus on it, right? So guys, I am requesting you that all of you please focus on the screen now, and I will give you extra time of 3 to 4 minutes for not that, right? But before noting this, please focus on the screen. So intermediate code is of two forms, that is, one is linear form and the another one is tree form. Linear form and the next one is tree form. And in linear form, further it is categorized into the two, that is postfix notation, postfix form, that is postfix intermediate code, and next is the very important, that is three address code, that is three address code. Okay, postfix code and three address code. And tree form, it is further categorized into two forms, that is syntax tree, that is syntax tree, and DAG, directed acyclic graph, that is DAG, directed acyclic graph, and syntax tree. So it is the formation, you can say that intermediate code is there, which is further derived, categorized into two forms. One is linear form and another is tree form. In linear form, it is again categorized into postfix and three address code, and in tree form it is categorized into syntax tree and directed acyclic graph, right? Now if you will focus, guys, suppose an example I am taking. Example is, suppose my example is, suppose a plus b multiply with a plus b plus c. Okay, this is, suppose I am taking as an example. So if I would make it with the help of postfix notation, it is same, Ashik, it is same Ashik, it is same. Okay, so if I talk about the postfix notation, then all of you know that the what is postfix notation of this. So in postfix notation, basically precedence is given, highest precedence is given to the braces. So a b plus would be the first key, then multiplication is there, and from this braces a b plus would be there, and c plus, and after this we can generate postfix notation as a b plus, and this multiplication will move to the rightmost position, that is a b plus c plus and multiplication. So it is the postfix notation, guys, it is the postfix notation corresponding to this example. So in intermediate code, this is the kind of linear form intermediate code under postfix notation. If I try to form it under three address code, then in three address code I need to take a variable, extra variable, that is t1, and in t1 I am adding a plus b. So this a plus b is now replaced with t1, and now next time what I am doing, next time I am again taking t2. So this t2 is adding this a plus b, this t2 is adding this a plus b. Okay, and again I am taking one more variable, that is t3, and this t3 will add t2 plus c. So this t2 is the value of a plus b, and it will add c to it. So the complete value of a plus b plus c I will get it by t3, and I am taking another variable t4, and it will simply what it will do, this is the T1 and this is T3, so it will multiply T1 with T3. So it is my respective three address code, TAC, it is the short form, and I can say it is three address code. It is the three address code for my this example, for my this code, right? So this is the code, and in three address code I can write it. Why I called it as a three address code? Because one address is there, the second one is there, and third one is there. So it is having three addresses. T1 maybe have a different location in memory, may have different location in memory, B may have different location in memory. So by combining all of this, we can say that this is generating somewhat three addresses, right? Because three variables are basically there. So this is the basic example of three address code of this example. So these are the linear forms of intermediate code. And three address code is very very important. And in our GATE syllabus as well, three address code is there. Basically, only 1% or 2% of GATE syllabus is revolve around three address code. Almost all the syllabus of compiler design we have completed yet. But still, three address code is an important part. And three address code is basically globally accepted code. It is a globally accepted code in all the compilers. That is why we consider this topic as important. Further, one more is there, that is a syntax tree. So syntax tree is nothing but multiplication symbol is there, then it will add two variables a and b, and here it will again add two variables, okay, that is a and b. So it will add a plus b here, and it will add a c to it, and it will generate it. So the syntax tree for this example would look like it is the syntax tree structure for our this example, right? So in that you can observe a plus b will be added here, and it will multiply with the result of a plus bc, like that. And if we consider DAG, directed acyclic graph, is basically you can say it is more efficient version of syntax tree. Why it is called as more efficient version of direct of syntax tree? Because here what it will do, it will add a plus b, and here if you will if you will check here, a and b again added here, means in directed acyclic graph, if a value is added already, it will not add it again, it will not do this operation again. So it will again add only c to it, and it will take the result of addition of a plus b directly from here. If it will not calculate this step is reduced in directed acyclic graph. That is why DAG is called as the efficient step of the syntax tree, because in DAG you can simply say that it will not gonna calculate same operations again and again. If a plus b is calculated once, it will not gonna calculate it again and again. So it is the clear differences of different forms of intermediate code, that is postfix form, three address code, syntax tree, and DAG. But in our GATE syllabus, we do only have three address code as a part of our syllabus, so we'll gonna discuss it, right? So guys, is it clear the forms of intermediate code to you? Please comment me, guys. Sorry, DAG and three address code I couldn't understand. Soumya, I didn't understand DAG and three address code. Okay, okay, Soumya, don't worry. I am discussing it once again. Don't worry. If you don't get it, don't worry. I am discussing it once again, right? Don't worry about it. Just focus here. Soumya, please focus here so that you can get it. My example was a plus b multiply with a plus b plus c, and I need to write this example. This is my code, and I need to write this code in a three address code. So the rule of three address code written is that I need to take a separate variable in which I will store this value. Three address code means it in each step, in each syntax, in each statement, maximum it can have only three addresses. That is why I am taking T1 as a separate variable, and I am assigning the T1 the value of a plus b. So T1 is having value of A plus B. So this A plus B is now replaced with T1. This A plus B is replaced with T1. So it is my first statement. And why I called it as a 3 address code? Because this is consisted 1 address, 2 address, 3 address. Because there is a place in memory where T1 will be stored. There is a place in the memory where A will be stored, and there will be place in the memory where B will get stored. That is why I say it as a 3 address code. Now again I am taking another variable T2 because I need to replace this block with 3 address code. So again T2 is, I can say it as at A plus B. So this A plus B is now calculated with T2. Or you can also say that T2 equals to, I can do it optimize, but I will not doing it here, right? So T2 equals to A plus B, and I am taking another variable T3, and this T3, this is now the A plus B is now hold the T2 will hold the value of A plus B. Whatever result A plus B will generate, this T2 will hold the result of that. Now if I will add the C, that is I will add C to T2, I will get the value of complete A plus B plus C. So in three statement I have written T1 and this T2. Now this complete block I can say it is a T3. Now what I need to do, I need to multiply T1 with T3. I need to multiply T1 with T3. So I am taking another variable T4, and what I did, I multiply it with T1 and T3. So the rule of 3 address code is take separate variable, and using maximum 3 addresses I need to replace it. I need to replace this example as a 3 code. So when this code is passed, when this code is passed to the as a high level language to the compiler will convert this code as a this in the term of intermediate code generation. In intermediate code generation, this would be look like this code will be look like is the representation of this example. So it is the 3 address code definition, guys. So is it clear now? Yes, Somya, it is similar to CO. Yes, 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 yes. And if I need to draw it in DAG, directed acyclic graph, if I will need to write, I have multiplication symbol here. I need to add A plus B on the left hand side because left hand side A plus B is here. So I will add A and B here, and on right hand side I have A plus B again, but A plus B is already calculated. So I will directly take value of A plus B and I will add it with the C. So it is my directed acyclic graph for tree, because this intermediate code can be generated in tree form, and I have two tree forms, syntax tree and directed acyclic graph. So this is the directed acyclic graph structure of the example of this code. Is it clear now that how to write 3 address code? Basically you just need to write it in like that, right? It is the 3 address code. Is it clear, guys? Okay, it is clear to show me. Okay, guys. Now suppose I can also write it like this code. I can also write it like, suppose I want to replace it. Then I had write T1 equals to A plus B. This A plus B I have written as a T1 equals to A plus B. Now I take T2, and I already have A plus B value as a T1. Now I already have T1 as a value of AB. So this T3, whatever this T3 is working, I can replace it here as well. That T2 is nothing but T1 plus C. T2 is nothing but T1 plus C, because T1 is what T1 is A plus B. So all I already have value of A plus B. So why I am doing it again? So I can replace this A plus B in T1 as itself, and I can add this C to this. So I can reduce one step. And in T3 I can multiply T1 with T2. In T3 I can multiply this T1 with T2. So it is nothing but my optimized code. It is nothing but my optimized code. Code optimization is done. Is it clear that how I done this optimized code, guys, from intermediate code generation? Unnecessary steps we are reducing. It is called as optimized code. Is it clear, guys? Can I move it? Can I move forward? Is it clear to everybody that what I had done? Okay, very good. Okay, guys, very good. Clear to everybody. Very good. Now let's see the very basic definition of the 3 address code. As a definition point of view, we can say 3 address code is nothing but it is a intermediate code generator. It is an intermediate code generator receives input from its predecessor phase, that whatever phase it have predecessor, like syntax analyzer, semantic analyzer, it will take input from that. And it, that is semantic analyzer is the predecessor phase of that, in the form of annotated syntax tree. And that syntax tree then can be converted into linear representation, whatever linear representation, postfix notation or intermediate code notation or three address code notation, we can say simply. And intermediate code tends to be machine independent code. Intermediate code is tends to be machine independent code. So when I discussed the phases of compiler design in our first session, I have discussed there are two phases of intermediate code generation. That one is machine independent code and another is machine dependent code. Machine independent code, all the code is independent on the operating system and the operating system of the and the configuration of the system. And in machine dependent, the code is dependent on the configuration of the machine, right? We have discussed in the first session, initial session. Therefore, code generators assumes to have unlimited number of memory storage register to generate a code. So it is nothing but just a theoretical part. You just can take a screenshot of it and we can move forward. So if you want to take a screenshot, guys, please take it and we can move one step forward. Okay, if you have done it with, just tell me you done so that I can move forward. Okay, so you can also take a screenshot of this, guys, this chart. You can also take a screenshot of it, and not in your notebook, because it is the various you can say that various type of intermediate code I have written here. So various forms of intermediate code, that is linear form, tree form. So you can take a screenshot of it also and I can move it forward. If you have done, then I can proceed forward, because it is important part. At least if you have a screenshot of it in your device, it will be beneficial for you while you will revise it, that you will exactly able to make differences between these forms, right? Okay, so now, guys, I am discussing the types of three address codes. Basically, we have seven types of we have seven types of three address codes, and the very first one is, you can make a note of it. The very first one is x equals to y operand z. So whenever we got this is one kind of three address code where this operand is nothing but it is having binary operation. It is nothing but it is having binary operation. So it is the one type of three address code. Means what, whenever we will see that x equals to a plus b or a plus b plus c, then we can replace a plus b like t1 equals to, suppose a plus b is termed as t2, then t2 plus t3, or we can say that t1 equals to a plus b, where this a is nothing but binary operation. Binary operation means operation between two operands. It is called as binary operation. So this is the one type of three address code. And the next type of three address code is x equals to operand z. Means it is nothing but it is unary operation. It is unary operation like plus z minus z, right? Means only one operand will be there. So this kind of operation will also part of three address code. So we are discussing here types of three address code. So first type of three address code is binary operation. It would be generalized in this form. Unary operation, it is generalized in this form. And the next one is, you can say x equals to y. This is the next type of three address code. It is nothing but it is the assignment form of, this is the assignment. Means we are assigning the value of y to the x. So this kind of operation is also, this is also type of three address code. So x equals to y, it is assignment operator. And in fourth one, we can simply say that if x, if it is a relational operator with y, we can go to L. Means it is a conditional go to statement is here. It is a conditional go to statement is here. It is a conditional go to condition. Means if this statement is true, if this condition true, if x relational operator whatever is true, like x is greater than y or x is less than y or x is greater than or equals to y or x is less than or equals to y or x equals to y, whatever is there, whatever relational operator is facing here, if it is true, then we can move to this. Means then we can move forward to go to L, whatever the next statement is there. Such kind is called as conditional go to. So it is again type of three address code. And the next one is Unconditional go to means without checking any condition we can go to the next statement. It is called as unconditional go to. Unconditional go to. And the next one is AI equals to X. It is nothing but the array indexing. Array indexing is also a type of three address code. Whenever we will see array indexing in our code, we can make intermediate code or three address code with that. So AI equals to X, or we can simply say that Y equals to AI. So it is nothing but array indexing. So array indexing is one of the type of the three address code. And the last one is the X equals to asterisk p, means pointer kind of thing, means one will hold the address of another one. Or we can say that Y equals to m%z or m%x. We can say Y is m%x, means address is assigned to other variable. Simply we can say that address is assigned here, address is assigned to other variable, address is assigned to other variable. So these are the 7 types of three address code which we are gonna replace. So whenever we see such kind of statements in our high level language code, or in our input of in the output of syntax analyzer, or we can simply say that in our code, we can make intermediate code generation, or simply we can say that we can generate three address code, with the help of this statement. So you can make a note of it, that the types of three address code with the heading of types of three address code, please make a note of it. And if you will done with that, please comment me done, so that I can move to the next one, guys. Please do it. It is a theoretical topic, so there is a need of doing it fastly, right? So please do it, guys. It is the types of three address code. Please write it, note it in your notebook, and we can move forward to our next slide, and we'll discuss the next topic of three address code, that is various representations of three address code. Okay, done. Very good, guys, you have done it very good. Okay, guys, the next topic is various representations of three address code. The next topic is important topic again, various representations of three address code, but it is lengthier topic. It will take 15 to 20 minutes. So I hope we can take a break of 5 minutes here. We can take a break. My fifth transition, I have T5 equals to A plus B, and in my sixth transition I have T6 equals to T5 plus C, and in my seventh transition I have T7 equals to T4 plus T6. Okay, and these are the three address code for which example? These are the three address code for minus A plus B multiply with C plus D addition of A plus B plus C. Okay, this is my statement, and in respect of this statement, this is my three address code. Okay, guys, we have discussed it already. Now the very important part is now to discuss various representations of three address code. So one of the representation of three address code is quadruple form. What I am saying? Quadruple form. Quadruple form means it will contain 4 entries in its table. The first entry will contains operator, next one will have A, and next one will have operand 1, next one will have operand 2, and last will store result. So these 4 entries I will have in the quadruple. So guys, focus on the screen, please don't get confused here. Focus on the screen. The first form, the various we are discussing various representations of three address codes. We are discussing various representations of three address code. In that, the first representation is quadruple means it will have 4 entries: operation, operand 1, operand 2, and result. So you can focus here so that you can get it better. Focus here. operand 1 in first statement, what operation we are performing? We are performing addition operation. So in operation table, plus will be here. Operand 1 is A and operand 2 is B. Operand A is A, operand B is B, and result will get stored in T1. The result of A plus B will get stored in T1. So it is the entry under quadruple table. Just focus on this one again. In quadruple entry of this T2, operand, what operand we have? We have operand negation. Negation we need to perform. What operand we have? We have only one operand, that is T1. So we will put T1 in this operand. We don't have second operand here, and so I will leave it blank, and result is stored in T2. Result is stored in T2. If we will focus on T3, what operation we are doing? We are doing addition operation. So I will put addition here. Operand 1 is my C is operand 1, so I will put C here. Operand 2 is D here, so I will put D here. And I am adding the result of C plus D in T3, so T3 will be here. Next one, if you will do, what operation is there? Multiplication operation is there, so I will put multiplication here, and operand 1 is T2, so I will put T2 here, and next is T3 is operand 2, so I will put T3 here, and multiplication of this T2 and T3 will be put into T4, so T4 would be here, because T4 is holding the multiplication of T2 and T3, right? Next T5, so what we are doing? We are doing addition operation of A and B, and I will write T5 here, because in T5 we are holding the value of A plus B again. Here we are doing addition operation, so in operation entry plus will be there. Operand 1 is T5 would be here. Operand 2 is C, so C would be here, and we are storing the value of T5 plus TC. We are reading the value and storing it in T6, so T6 would be here. And the next one is plus, addition symbol is here, and we are adding T4 and T6 here. We are adding T4 and T6 here, and we are storing the value of T4 plus T6 in T7, so T7 should be there. So guys, it is quadruple representation of 3 address code. Is it clear to everybody? Just a theoretical topic, it is not important for GATE, but I am discussing it because it is a syllabus under GATE, that is why I am discussing, but not important as of the GATE. But are you getting the how to construct quadruple, guys? Are you getting how to construct quadruple table? Is it clear to everybody? Or if anybody have doubt, please tell me, I will solve it once again, don't worry. If anybody have doubt, please ask me, else I will focus on the next representation of 3 address code. Is it clear to everybody now? Because it is very simple representation. Okay, it is clear to everybody. Very good. Now guys, you can make a note in the quadruple table. Just make a quadruple table, and in the note of one I am dictating the advantage of, just you need to write it in your notebook. The advantage of quadruple form of representation is, I am dictating, please write it in your notebook. The advantage of quadruple form of representation is statements can be moved around. Statements can be moved around. Statements can be moved around. It is the advantage of quadruple form. It is the advantage of quadruple form. It is the advantage of quadruple form. But disadvantage of quadruple form is that too much space is wasted. The disadvantage is too much space is wasted. Too much space is wasted. It is the disadvantage of quadruple form. It is the disadvantage of quadruple form. And the advantage is statements can be moved around, but disadvantage is too much space is wasted. Okay guys, now the next form of representation is triples. The next form of the representation is triples. Okay, triples are the next step of the next representation of the 3 address code. And in triples we only have 3 entries. We only have 3 entries in our table. What entries we have? We have operand entries, we have operation entries, we have operand 1 entries and we have operand 2 entries. So how I will write for first the entry of first would be write like 1 operand is plus a and b. So guys, whenever I need to call, suppose the entry of second would be look like negative and operand 1 is 1, means I can I am storing the value of plus a and b in the first statement. So whenever I need the result of 1, I will call 1. I will call the address of 1. This address of 1 will hold the value of this 1. So whenever I need the value of 1, whenever I need the value of this statement, I will just call 1. By the address of this 1, I will use pointers, and by the address of 1, I will fetch the value of this statement. So this is the entries in triples. How I will write third statement? Simple. Third statement is operand in plus. I am holding the value of C and D. In fourth statement, I will write multiplication is my operation. I will hold the value of T2 and T3 here. In my fifth statement, what I have? In my fifth statement, I have addition operation with A and B. In my sixth statement, I have addition of T5, and that is T5 is nothing here now, so 5. T2 is nothing here, so what I will do, I will call 2. T3 is nothing here, so I will call 3 here, and I will add C here. And in 7th entry I need to addition of T4, that is I will call 4th statement, and I will add it with 6th statement. This is entry of 7th table, it is entry of 6th, 5th, 4th, 3rd, 2 and 1. It is my triple table, guys. So in triple table I have reduced the result value, and whenever I need result of any step, whenever I will need a result of any space, I will call it by the number, by the row number. Whatever row number it have, I will put the address of it. By address of that row, I will call the result of that. By calling 1, I will fetch the result of a plus b. By calling 2, I will fetch the result of minus 1. By putting 5, I will fetch the result of this a plus b. By fetching 4 plus 6, I will do, I will take this 4, the result of this one will be added with result of this one. So this is the triples form of representation under 3 address code. But there is a disadvantage, guys, because the advantage here is statements can be moved around, where in quadruple, but here statements can't be moved, because if I called second statement first, but then it will create error because I don't have result of one and I directly called second. So in that case it will create error for me, because I need to do it sequentially. If I will change the sequence, means I can't change my statements, I can't move the statements here. It is the disadvantage of it. But advantage is that space is reduced, space is not wasted. So guys, it is the triple form of representation in TAC, that is 3 address code. Is it clear to everybody? It is a theoretical concept, it is a complete subjective concept. No need to take that much load, but as a perspective of GATE syllabus, you need to have knowledge that what is quadruples, what are triples, so that I am discussing it. So guys, is it clear, the concept of quadruples and triples to you? The concept of quadruples and triples are clear to you or not, guys? Please answer me. Please answer me, guys. Is it clear to everybody now, the concept of triples? Okay. Now I am moving to the last representation of 3 address code, and it is called as indirect triples. What it is called as? It is called as indirect triples. It is the last form. The very first form was quadruples. It is the first form of 3 address code. The second form of 3 address code is triples, and the last one, that is third one, is indirect triples. So in indirect triples, first entry would be called by 1. Means whenever I need to call 1, I will just call 1. So basically indirect triples are it works on the basis of triples, but I do not need to make triples in my current memory. These triples will be stored in my memory. These triples will get stored in my memory. These triples will get stored in my memory, and in indirect triple, I will make a pointer of this one. I will make a pointer of this two. I will make pointer of this three. I will make pointer of this four. I will make pointer of this five. I will make pointer of this 6, I will make pointer of this 7. And whenever I need to call any statement, suppose I need to call second statement, I will call second pointer. If I need to call third statement, I will call third statement. If I need to call fourth statement, I will just call fourth statement. If I need to fetch fifth statement, I will call fifth statement. If I need sixth statement, I will just call sixth. And if I need seventh statement, I will put seventh pointer. This will fetch the value. So this is indirect triples. Indirect triples works on the basis of triples, but triples will stored in the memory, and this pointers will fetch the value of that respective statement directly from there. So it is the indirect triple representation of 3 address code. Is it clear, guys? Is it clear to you or not? Please answer me. Is it clear to everybody? The concept of 3 address code. Is it clear to everybody? Is it clear to everybody, guys? Okay. Now we are coming, guys. Please repeat indirect triples. Okay, Ashik. I am repeating indirect triples as you have commented. All candidates can focus. Indirect triples will work on the basis of triples. And what is triples? This is the triples. What is triples? What are triples? These are the entries of triples. These are the entries of triples. So indirect triple will work. Indirect triple will work on the basis of these triples. But triples will get stored on the memory. Okay, triples will get stored in the memory. Now indirect triples, suppose I need to call first statement. Then I will create first pointer, and this first pointer will fetch the value of this statement for me. That is why it is called as indirect. Indirect itself means that it will indirectly fetch the value for me. It will indirectly fetch the result for me. So pointer 1 will fetch the value of first statement. Similarly, pointer 2 will fetch the value of this statement. Similarly, pointer 3 will fetch the value of this statement. Similarly, pointer 4, 5, 6 and 7 will fetch the respective value of 4, 5, 6, 7. Means if I call 4, then it will multiply T2 with T3 and give me the result of T2 to T3 to me indirectly by using pointers. So Manjit, Ashik, is it clear to you or not? It is indirectly taking the value on the basis of triples, which is stored in main memory. Is it clear, Ashik? Number of states equals to number. Yes, Ashik, we can say that number of states or number of variables on the keyword number of states. Betterly, we can say it as a number of keywords, number of variables. Number of variables equal to number of pointers. Whatever number of variables we have. Suppose we have 7 variables like T1, T2, T3, T4, T5, T6, T7. Then we need 7 pointers. Okay. So number of variables will be equal to number of pointers in indirect triples. Okay, guys. Now, guys, we are coming to get 2015 question, which is based on 3 address code, which is completely based on 3 address code. That is the remaining 2% of the questions are asked, but they are not asking that much questions now. But yes, 3 address is an important concept. That is why we are discussing it. So the last topic of GATE computer science means weighted topic we can say is this, and the question is in front of you, guys. The question is the least number of temporary variables required to create a 3 address code in static single assignment form for the expression this for this following expression Least number of temporary variables for static single assignment. For static single assignment, so guys, answer me. When you will create three address code for the following expression using static single assignment means every time you need to create separate variable. Static single assignment means you can't repeat one variable again. You can't repeat one variable again on the left hand side. On the left hand side you can't repeat one variable again. It means that static single assignment. So how many least number of temporary variable will be required to express the following expression? Please guys answer me. I am giving you 3 minutes. Please make three address code using the explanation which I have discussed with you earlier in this session, and please try it, and after that I will discuss the solution. Please try it guys, please try it. Very important question. I am giving you 3 minutes and expecting every candidate to answer. Very important questions. Please try, all the candidates, please try this question. Very important question of three address code. It is a GATE 2015 question for 2 marks. Please try it and answer me that how many minimum number of temporary variables we will be required to create three address code. I am expecting every candidate to answer. I got answer from Ashik, Nikhil and Manjit, but answers are different. Please verify guys, please verify why you are getting different answers. Please verify. Oshali has answered B. Okay. Manjit has answered B. Nikhil has answered C. Ashik has answered C. Okay, 4 answers I have got yet. Requesting other candidate as well that please guys answer it. Okay guys, you can see, you can take a hint because you guys are getting different answers. That is why I am giving you hint. You know that the higher precedences of divide, that is divisor operation, divisor operator and multiplication operator have equal precedence, but they have higher precedence than addition and negation. So you just need to take a separate variable for r divided by 3 first, then you need to take separate variable for t into 5, then you need separate variable for u into v, and whatever result u and v will form, you will take a division of w with that, because you need to take a precedence with that. After that you need to calculate addition, and you, because you need to take a concept of precedence, you need to take concept of precedence plus associativity, right? You need to take that which operator is having higher precedence, and what operator have what kind of associativity, whether it is left associative or right associative. So on the basis of that you can create the new variables and separate variables, right? So okay, I got answer from Nikhil, Soumya, Piyush, Ashik, Poshali, Manjit. Okay, so guys, just focus here now. Just focus on the solution now. Just focus on the solution. Initially, we took a separate variable t1, and t1 is holding the value of r divided by 3. That is, whatever value r divided by 3 will hold, it is stored in t1. And Now we are taking value of t into 5. You will ask me, sir, why we are not going sequentially? Because I told you now, we need to go with precedence as well as associativity. So precedence of division operator and multiplication operator are equal. But associativity is from left to right. Associativity is from left to right. That is why we have calculated this one first. After that, we have calculated this one. Now we need to calculate the result of u and 2v, but before that t2 I can write it t into 5. Okay, after that I will take a separate variable t3 and I will calculate the value of u into v, into u multiply with v, and I will take next, and this u and v will be replaced with t3, and now according to the associativity I will write t4 as a t3 divide with w. So this t3 divide with w, this is completely now stored in t4. Now again I need to go with left to right because I just remaining with the addition operation and subtraction operator, which both have equal precedence, but from left to right. So t5, in t5 what I will do, I will add q to the result of r divided by 3. R divided by 3 is t1, r divided by 3 is t1. So in t5 I will hold the value of q plus t1. It is in T6 what I will do, I will add S to it. To whom I will add S? I will add complete result of this, that is T5, and I will add T5 plus S, that is the complete result of T5 plus S will be stored in T6. Okay, now in T7 I need to do subtraction of this portion to this portion. So t into 5 is nothing but t2, so it is t2. So I need to subtract t5, that is this t5 I need to subtract from this t2 minus t2, and it will be got stored in t7, and after that I have t8, and I will what I will do, complete result of this is complete result till there I have t7, so I will do t7 plus t4. T4 is this, so t4 plus t7, it will be got stored in t8. So guys, you will observe here that at least the list number of temporary variables are 8 in 3 address code. So option B is the correct answer. It is the GATE 2015 question for 2 marks. I hope all of you got the answer. Guys, do you have any kind of problem in this? If you have any kind of problem in the solution of this question, please ask me, else I can go for the next question. Guys, is it clear to everybody? Please comment in the chat box. Is it clear to everybody? So that I can move to the next question, guys. Is the solution and the explanation is clear to everybody, guys? Do anybody have problem in that? Do anybody have any kind of doubt or query in this problem? Okay, it is clear to everybody. Very good, guys, very good. Next question is in front of you. It is also a GATE question, guys. It is previous year GATE question in front of you. Question again is the minimum number of variables required in 3 address code of the given expression. And order of precedence is in front of you. Order of precedence is in front of you. Multiplication symbol have higher precedence than plus. Plus symbol is higher precedence than subtraction. And multiplication symbol is left associative, and addition and subtraction symbol have right associative. So it is very interesting question, and it is a numeral question. It is a numeral kind of question which is asked in GATE exam. It is a numeral question which is asked in the GATE exam. I am giving you 3 minutes, guys, to answer this question. It is 3-minute question to answer. You just need to make 3 address code for the following expression and need to answer me. I am giving 3 minutes to answer this question. Very important question. GATE previous year question. Very important question, guys, because here associativity you have to follow, and you need to keep in mind the order of precedence for each operator. I am giving 3 minutes for this question. After that I will discuss the complete solution with detail and analyze the question as well. Please answer me this. Okay, I got answer from two candidates. I am waiting for other candidates as well. Please answer it, guys. Very important question. I am expecting other candidates as well that please answer this question. It is very interesting question, guys. Very interesting. You will gonna clear so many concepts with this question. It is a previous year gate question. Very important question. Very important question. And I will clear a very important concept with the help of this question to you. But please try, guys. Please try. I am expecting every other candidate as well that please try. After that I will gonna discuss answer. Please try, guys. Okay, guys. Now I am discussing the solution with you. Now I am discussing the solution with you. Please focus here. Please focus here. Actually, this question has asked the minimum number of variables required in three address code of the given expression. Okay. Previous question was the okay. Let us clear the doubt that what is the exact difference between previous question and this question. Previous question was just 2 seconds, guys. Previous question was the list number of temporary variables required to create a three address code in static single assignment. Static single assignment. So guys, not important definition. Please not an important definition that static single assignment. What is static single assignment? It is a three address code variation in that if we will declare a variable, suppose t1 we have declared a variable, then we cannot use t1 again on the left hand side. Suppose I use t1 equals to a plus b, t2 equals to a plus c, then I cannot reuse it. I can't reuse t1 again. It does means that static single assignment. It is the meaning of static single assignment, that I can't reuse it. But in this question we need to answer three address code, but here it doesn't mention anywhere that it should be done with the help of static single assignment. Means you can see the solution. First t1 is used, and what t1 calculated a into b, because multiplication is left associative, as well as this operation, the precedence of multiplication is higher. So what I did, t1 is calculated as a into b. Okay, guys. Now a into b, it is calculated as a t1. Now what I need to do, I need to multiply t1 with c. So again I reuse t1 and I am multiplying t1 with c. What it means, that I have a into b into c. Okay, I have a into b into c. So first a into b will be solved. It is stored in t1. So whatever value t1 is storing, whatever value this t1 is storing, we are reusing t1 again. We are reusing t1 again because I need to multiply this t1 with this c. But I am not changing my variable. I am keeping this variable same. Why? because it is a multiplication. In multiplication operation, suppose I do have a into b into c into d into e, then in that I will suppose do t1 here. I will multiply t1 equals to a into b first. After that I will multiply t1 equals to t1 into c. Again result is stored in the same, so I will do t1 equals to t1 into d. Again result is stored in the same, so I will do t1 equals to t1 into e. And this is the complete result of a into b into c, because multiplications are together, they are mentioned together. If multiplication operations are mentioned together, means I can reuse it until and unless I have multiplication operation as a adjacent. Now in the next one I need to use what I need to do, I need to add the result of this t1 with this d. So what I am doing, I am again using the same operation t1 and I am adding the t1 with d. No problem yet. Now I don't have any problem yet, because if you will see here why I am doing it, because if you will see the precedence of multiplication is higher, and after that precedence of plus and minus is there, but plus and minus is right associative. So you can simply say that multiplication will not gonna any impact, and this e and f will need to calculate from separate variable. Why? Because I cannot use t1 up till here. Why? Because plus and minus have associativity started from right to left. So this e, for calculation of this e and f, I need a separate variable, that is t2, and t2 will be calculated as e and f. Okay. Now now the second is the associativity of this plus is higher, but the order of precedence is plus is higher than negation, but associativity is right, but I can't calculate this plus first now, because if I have this result as a t2, then a plus t2 will be gonna calculated at a first step. So I can rewrite as a minimum, because why I am doing it, because in question it is mentioned that minimum number of variables I need. So minimum number of variables I need, that is why I am changing the sequence of it. So I can rewrite it as a t2 equals to t2 plus a, that is t2 equals to this t2 plus a. So until here I done it. Now after that I need g plus s, because I have done all the multiplication symbol, and I have done this plus one before. Why? Because I need minimum. So in my mind I need to clarify that what execution, what statement, what operation I will do first, so that my variable should be minimum. Now after that it is compulsion for me that I need to calculate g plus h, because I can't calculate negation first. Why? Because the precedence of plus is higher. So g plus h will be calculated with the help of remaining the next variable, that is t3 will be calculate the value of g plus h. Now this is holding the value of t3. Now what I need to do, I need to calculate t2 minus t3, because all plus symbol has calculated, all additional operation or addition operation has calculated, and I am remaining with two negation operation now, and the associativity of negation is from right to left. So what I will do, I will store the value of t2 minus t3 in the left hand side of variable, that is in t2 itself I will store the value of this one, and now I am remaining with t1. So in the left side variable, that is t1, I will store the value of t1, and I will subtract this value with the result of this, and the result of this is nothing but t2. So t1 minus t2 is gonna store like that. So these steps are basically mathematical true statements. If you will run, this is the mathematical true statements. Why? Because if you will run this statement, if you will run these statements on compiler, in three variable it will done, if I don't put any condition. But guys who have answered it is correct answer. If I put single static assignment here, if I add, you have to done it with single static assignment. If I will do that with the help of single static assignment, you have to perform it, then 8 is the correct answer. because you will not reuse any variable again and again in single static assignment. That is why 8 is correct answer at that time, but single static assignment was not mentioned in that question. So we need to check all the possibility that where we can reuse the variable again and again. Whatever the possibility of using any variable on the left hand side, we can reuse until and unless we are not violating rules of the question, that is the precedence and associativity. If we are violating the rules, means we need to take next variable and we need to do it with the separate variable. So this was the concept GATE has asked in 2 marks with this question. Guys, is this question clear to everybody? Because it is very important question. And if you got the clear exact difference between single static assignment and without single static assignment, it is clear to all of you then. Because it is very important to learn that what is the exact difference between single static assignment, because in single static assignment we can't use, here if you will observe, we didn't use any variable on the left hand side. On the left hand side we didn't use any variable again and again, we use separate variable because static single assignment is there. So whenever in the questions static single assignment would be there, we will use separate variables. But if single static assignment is not there, then we just need to use our aptitude, we just need to use our common sense, and we by our mathematical skills we need to answer that what are the possibility in which we can reduce the variable size. So that is why 3 is the correct answer for that. Is it clear to everybody, guys? Can I move to the next question now? Is it clear to everybody now? Okay, clear. Okay guys, so the next question is in front of you now. Next question is in front of you. Now focus on the question once again, because now I hope you got all the clarity. Question is, consider the following intermediate program in the address code. Program is P equals to A minus B, Q equals to P into C, P equals to U into V, and Q equals to P plus Q. Now the question is which one of the following corresponds to a static single assignment from the above code? From the above code, which one of the following corresponds to static single assignment? Again, very important part is there that you need to keep in mind is the concept of single static assignment. So which one of the following corresponds to a static single assignment from the above code? You have 4 options. Answer me guys, answer me. I am giving you 3 minutes to scan all the statements of all the options, and then please answer me that which of the following is the correct answer for this question, because it is very important question. Is my screen is visible, guys? Manjit has answered that not visible. Is my screen is visible to everybody? Is my screen and audio is visible and hearable? Guys, am I audible to all of you? And is my screen is visible to everybody? Please comment in the chat box. Okay guys, so question is in front of you. I am giving you 3 minutes to answer this question. It is very important question of GATE exam. You must need to answer it, guys. Very important question of GATE exam. Previous year GATE exam, the following intermediate program is given to you. You need to take a concept of single static assignment and need to answer me that out of A, B, C, D, which of the following is the correct answer. Please answer me. Very important question. I am giving you 3 minutes. Think, verify answer. Okay, before giving answer, please verify it. And I am expecting everybody to answer it, guys. Please answer it. Okay guys, answer me. D. Okay. I am expecting every candidate. Hello guys, I am expecting every candidate to answer this question because it is very important question. You all need to answer. I got several answers, but answers of all candidates are different. Everybody is answering A, B, D. Okay. Guys, please verify it. Please verify it. I am giving 1 more minute. After that, I will discuss the complete solution. One by one, I will discuss the solution, guys. Don't worry. One by one, I will discuss the solution. Okay. Okay. Just 30 more seconds, guys. 30 more seconds. After that, I will gonna discuss solution. Okay. Okay, guys. So now you can. Many candidates answered D and B and A. Okay, so guys, I am scanning the solution. I am scanning. I am telling you the answer here. Please focus on the screen. I am telling you the answer, guys. Now, please focus on the screen. Please focus on the screen. If we take the answers, the candidates who have given the answer A, the candidates who have given answer A. Please focus here. Please focus here. That here static single assignment is given. If static single assignment is given, then a variable which is already declared p1, we cannot use p1 again on the left hand side. If it is declared once, it cannot be declared once again. That is why statement A is not the correct answer. Okay, it is the rule in static single assignment. That is why option A is the incorrect, because p1 is declared once again, which is violating the rule of static single assignment. Now focus on statement C. Statement C, focus guys. Here what we are doing, P1 equals to A minus B. Okay, it is correct. But what we are doing with Q1? We are doing Q1 as a P2 into C. But P2 is not declared before that. Where is P2? P2 is not assigned any result. Na? Where this P2 come from? What is the existence of P2? The existence of this P2 is not clear to us, because this P2 is not cleared. That is why option C is also incorrect. Focus on this statement. According to static single assignment, a variable cannot be used more than once in the left hand side. In the left hand side, the variable cannot be used more than once. That is why option A is false. The next one, a variable should be initialized at most once. A variable should be initialized at most once. But if you will focus here, we didn't declared P2, and we are using P2 in the form of Q1, that Q1 equals to P2 into C. So what is the value of P2? P2 is the variable we are using without declaring it. So at least it should have to declare at most once. That is why option C is also incorrect. And the candidates who have answered option D as the correct answer, please focus here. P1 equals to A minus B. It is okay, no problem. P1 equals to A minus B, okay. Q1 equals to P into C. If you will observe here, Q2 equals to P plus Q is incorrect. Why? Because if you will see here, P2 equals to U into V is there, and Q2 equals to P plus Q. But P plus Q, if you will observe here, in Q2, the grammar is in front of you, and if you will observe, because without moving it to register, we are using it. P plus Q is used as a Q2. Q is equals to P plus Q. And without moving it to register, we are directly using Q2. That Q2 equals to P plus Q. Where other parts goes? Other parts. What is the existence of other results? So it is invalid code. So option D is also invalid because there isn't existence of the upper ones. What is the existence of upper one? Okay, this is okay, but it will not accept this one na, because at the last position you need to conclude it, but it is not moving to the register. The upper results are not moving to the registers in the memory. That is why option D is also incorrect. Now focus on option B. We used P3 as a variable. We can use any variable. Suppose I can use P3, P4, P5. It is a name. I can use my naming constructions. I can use any name, whatever I want to give. So P3 equals to A minus B. Okay. Q4 equals to P3 into C. P3 into C. So P3 is nothing but A minus B. A minus B is stored as a P. So I have stored A minus B as a P3. So in Q4 I have done it like P3 into C. So it is okay. And in P4 I have stored the value of U into V. And in Q5 P plus Q should be there. So the what is value of P? P value is P4. So P4 is there. And the value of the P3 into C, that is Q. Value of Q is P into C. So it should be Q4. And it is accepted. But in option D it is not accepted, because here on the place of Q2 it should be like Q1 plus P2, but it is not Q1 plus P2, it is P plus Q. Without moving into register we are using values here. That is why option D is incorrect. But option B is correct, because at the last Q5 P4 plus Q4 is there, and it is accepting our intermediate program. That is why option B is the correct. This is the detailed solution, guys. You can make a screenshot of it. You can take a screenshot of it and tell me that whether you are clear with the solution, whether you are clear with this concept or not, guys. Please tell me.